All right, College Trade, here's our first installment of our take-home notes. 5.1, angles and their measures. So first thing we're going to talk about here is that we're going to now talk about two ways in which we can measure angles. You guys should be familiar with degrees, okay? But now our new thing that we're going to talk about is radians. Don't be too confused with radians. It's just like when we're using a ruler to measure objects. We have two ways to measure them. We have centimeters, okay, and we have inches, okay? So we're measuring the same distances, okay, but we have two different ways of saying it. So just like with angles, we can measure them in degrees and radians. Radians are a unit of measure, and we'll do some activities in class to solidify this, but understanding that it's related to its circumference and the arc length it measures. So the circumference of a circle is going to be 2 pi when the radius is 1. So now how we're going to define an angle is going to be based upon how much distance it covers around the circle. So a fourth of a way around the circle, if the whole circle is 2 pi divided by 4 is pi over 2, so you can see there's radian measures. Okay? So we'll talk more about this and do some activities in class with radians, but just know that we're going to be dealing with two ways of measuring angles in this course. So first bit of terminology that we need to talk about is just some basics on angles. An angle is formed by two rays. You have your initial side, you have your terminal side. Your terminal side is the side that the angle ends on. And then your angle is the angle between your initial side and your terminal side. Okay? In this course, this is going to be very important, that counterclockwise rotation. So the way opposite the hands of a clock go, okay, that is going to be considered a positive angle. We're turning in this fashion counterclockwise. If we have a clockwise rotation, moving in the direction that a clock moves, okay, we're going to define that as a negative angle. So an angle can both be represented positively and negatively. A terminal side can be represented positively and negatively. So if this is our initial side, the positive angle to this terminal side is alpha, and we could define it in a negative angle this way. In this course, we're no longer dealing with angles just based between 0 and 180 degrees like we thought about when we were dealing with protractors. But now we're going to deal with things on rotational values, because rotational values are going to be super important in the areas of physics and things of that nature, that we don't only want to know an angle between two lines, but I want to know how many times something might revolve around something. So we could have larger than 360-degree angles, essentially. All right, so some vocab that we want to get out of the way here. So standard position of an angle. The standard position of an angle, the vertex is at the origin and the initial side on the x-axis. So you can see our initial side here is on our x-axis, and here's our x-axis, and our terminal side is out here, and the vertex being at our origin. Okay, so that is what we refer to as standard position of an angle. A reference angle is going to be really important in relating angles that have similar values in different quadrants around, but it's your reference angle. Your reference angle is always the closest angular distance to the x-axis. So it's never coming from the y-axis, so don't try and do it from the y-axis. This is a no-no. We're always going to make our angles for a reference angle go from our x-axis up to our terminal side. Notice it's not starting at the initial side of our angle. That would always be our standard position. Yes, angles in the first quadrant will have the same position vector, standard position vector, and reference angle. So next we got to remind ourselves of our quadrants when we split up our Cartesian plane. You should understand our quadrant 1 here is when we have a positive x value and a positive y value. Our quadrant 2 is when we're going to have a negative x value, a positive y value. A quadrant 3 is going to be being both negative x and negative y. And quadrant 4 being a positive x and a negative y value. These quadrants are going to be very important throughout our semester here, so make sure you understand them. Notice that most quadrants are given the number based in Roman numerals, and that's pretty specific and standardized there. So, for instance, going back to our standard angles, standard position angles, and reference angles. So, if you're in quadrant 1, your reference angle is the same as your position vector. So in quadrant 2, if this is your standard angle there, notice that your reference angle is not the same. It's actually going to be that angular distance. You have a quadrant 3 angle. Your reference angle is your shortest angular distance to your x-axis. So this would be your reference angle. And then again, for quadrant 4, your reference angle is shortest angular distance to the x-axis. So reference angles will be important along with our quadrants. This is going to go ahead and wrap up our first segment of this video. We'll break it up into parts 2. So go ahead and watch that one next.